Welcome. Internationalization is a problem that all programmers have to deal with at one point in their work. Who remembers the first encoding bug that they had in their own code? I see some hands raised. Very good. I remember mine. Long ago, I was a young researcher in bioinformatics. I was working on a project called Wiki Pathways. And being a research website, there were lots of citations of scientific articles. And you can see here in the bibliography that there are some encoding problems. And I remember we were doing this research project together with some people in San Francisco, some researchers. And I remember discussing it with a colleague in San Francisco, and he suggested, well, what if we just strip out all the accents? Then we don't have any more encoding problems. And that didn't really sit right with me. I think that's sweeping the problem under the rug. And I noticed the same attitude when it comes to time zones. For example, just look at this thumbnail of this YouTuber, Code Opinion. He just comes right out in the thumbnail saying, I hate time zones. Well, that's an opinion. Or look at Tom Scott being clearly very frustrated here when he's ranting about time zones. So that is a common pattern, and it's a little bit of a pet peeve of mine. Like, what happened to, we're programmers, we can do it. We can raise to the challenge. Remember what Kennedy said in his speech on the landing on the moon. We do these things not because they're easy, but because they're hard. We love a challenge. For programmers, this usually turns into, we do these things not because they're easy, but because we thought they were going to be easy. But still, you have to admire the positive attitude, just diving straight in, right? So this is a pet peeve of mine, and I see it as my mission to, to help with this positive attitude toward internationalization problems. So who am I? My name is Martijn van Iersel. I work at Topdesk, nowadays as a technical product owner. I also host internal trainings at Topdesk, and that's where this all comes from. I'm interested in gaming, computing, biology. I mentioned, I started my career in bioinformatics, and education. So for the trainings I organize, and there was one training about internationalization, I always try to gamify it a little. And so for the internationalization, I started making puzzles. And I ended up making, it went a little bit out of hand. I ended up making 20 puzzles, and I published them online in an event this March. I will tell you a lot more about that later. But it was all inspired by the advent of code. Who here has heard of advent of code? Oh, that's at least 70% of the audience. And then, okay, so raise your hand if you have participated in advent of code. If you have reached 50 stars one year. Oh, that's only a hand, only 5, 10 maybe. And if you have reached 500 stars, no hands. Okay, I haven't reached 500 either. So for those who don't know what Advent of Code is a series of programming challenges that are published by Erik Wassel in the days leading up to Christmas. And it's there for 10 years already. So this was the screen that you get when you solved everything this year. So celebrating 10 years. And it's extremely popular. If you look at this slide, you can see the statistics of how many people participated last year. And the first puzzle was solved by over 250,000 people. So that's like lots of programmers really love puzzles. And so I started making my own puzzles about internationalization with an educational idea behind it. Each puzzle is about a different aspect of internationalization. Things like UTF-8 and UTF-16 and things with time zones and daylight saving time. And so there's 20 of all. Each of them they come with, let's say, a learning objective. And you can see all of them here. And the plan for today, what I'm going to do is I'm going to take you through 4 of these puzzles. And in addition to that, I'm going to tell you about the event in March, where I published them one by one. So I'm going to tell you how it went and who won in the end. And I should mention that this is also a spoiler warning. I say that for the YouTube recording because for everybody in the audience, it's too late. You're going to get these puzzles spoiled. But it's a warning for people watching the recording. And I don't say that unnecessarily. I have a reason for that, which I'll also come to later. But I'm first going to take you through one of the puzzles, number 12. It's called Sorting It Out. And I take this as a nice example of how the system works, so you can get an idea. So each puzzle also comes with a little story. And in this case, the story is that you're working at this company called Disrupto Corp. And they do something with AI innovation and blockchain and everything fancy and modern. And they're a little bit chaotic, a little bit disorganized. They don't really know who's working there. And you arrive there as an intern, and you're supposed to make a phone book for them, so that they know at least who is there, like a little phone book. And since they also don't really have standardized on any internet software yet, because they try something new every week, it's more convenient actually to just print it out on paper. So you start collecting names, and you come up with a list like this. And so the idea behind this puzzle is to challenge assumptions about names, about human names. Right? So I really did my best to pick some really unusual names here. I've got names like, in Dutch it's common to have what you may call an infix in the name. So my own name, Van Iersel. Van is an infix. But there are also names without an infix, like zonder van. There are double first names, like Jan Peter. In Spanish, it's common to have 2 family names. So on the top you see there Ñegues Peña as 2 different family names. By the way, in Spanish it's really uncommon to have a word that starts with Ñ, but I found one. And also names, first names with infixes, like Maria de Los Angeles. So, lots of unusual names here. And now, the puzzle asks you, well, if you have to sort this list, which of these 3 is correct? So I'll help you out a little bit by highlighting a few. Here, do you think Rosa Maria Auberg needs to come after Alvar Aalto or after Jan Peter Zondervan? What do you think? Okay, already getting one data point there. Do you think that Harm van der Heijden should be sorted with the V's, just like Willy van der Steen, or with the H, just before Floor van Leeuwen? Who thinks that the left one is right? Raise your hand. Okay, I see maybe 10 hands. Who thinks the middle one is right? 5 hands. And who thinks the right one is right? That should be the rest then. Well, I see more hands now, yes. The answer is, of course, it depends on which locale you're in. So on the left is what you usually see in English. The middle is Swedish, and the right one is Dutch, where you ignore the infixes when sorting. But that's different again from Flemish, where you should include the infixes. So. And then to solve the puzzle, you have to write a program to write these 3 sorting algorithms, then take the middle phone number, multiply them together, because that's what you usually do with phone numbers. And then the number that you get out, the final result, is what you submit on the puzzle site, and then it tells you if you solved it right or not. So that's how the system works. And now let's look at some possible solutions for this. So the first one I wrote myself in TypeScript. And there's a lot of code. You can see this really nice, or nasty, if you will, a regular expression to detect the first capital letter. But I want to highlight this. In TypeScript or in JavaScript in the browser, you can rely on the international collator class, which can help you do sorting in different locales. Now, imagine that outside of the context of the puzzle, imagine that this is a real-world application, application that is showing a phone book, and it has to do some sorting there. What kind of performance problem could this lead to? Any ideas? Anybody want to shout something? So, it's a trick question. If you do the sorting only in the front end, but you get the data from the back end, you're not loading the entire phone book into the front end. That would kill performance, right? You load it page by page. So at the very minimum, you should also do the sorting in the back end. So that's why we have some Java code here. And I want to highlight here that, so in the top block, well, in the bottom block, you see that, again, we use a collator object. Also, Java provides locale-based collators. But we have to do some special casing in the top block because the collation is slightly different the way it works in Java than it works in TypeScript or in JavaScript. And I think that's simply because collation is not very well standardized. It's not really. There's a lot of like old lore and the way librarians used to do things, and that's just different from place to place. But there's still also a performance problem with this application. Can anybody think of what the performance problem is here? Memory allocation. Well, if you load the entire phone book in memory, then indeed that would not work. So what you do is you get it from the database. And in the database, it also has to be sorted. Otherwise, you get random pages of data out. So I tried to solve the same script. Oh, by the way, I should mention this previous solution was from somebody who submitted the puzzles on GitHub. So I'm also trying to show you some of the solutions that people have submitted. But this one is my own. I tried to solve it with pure SQL as well, which can be done. It's not pretty. And then you can do some pre-processing in Java if you want, but we really have to store the collated data as a column so that you can build an index on it and get it really fast. In this case, by the way, we're using Danish collation rather than Swedish because it fits, for some reason, it fits the criteria of the puzzle better, which again goes to show that this is all not very well standardized. So, but the general theme is collation. Oh, and by the way, at Topdesk, we cannot solve this problem because our database layer is a little bit restrictive and we cannot have different collations on different columns. And so, unfortunately, in Topdesk, our Swedish customers never get the ordering that they want. So, it's a known issue. But now I want to talk about the event. So, last year, I was also here at Devox, and I made an announcement that I would publish all my puzzles. And at that time, they weren't ready yet, but I made a commitment back then. And so I published them in March. I ended up making 20 puzzles in total. And now it's time to look back at what happened. So at the start, my colleague, Roel, warned me. It's like, is your website ready to handle the load? What if it goes viral? Because, I mean, that's not such a strange question, because if you hear whenever Erik Wassel talks about the advent of code, he's always talking about how it went viral and how he was struggling to keep up with the load. So what I did some testing. This was the stack that I was using. I know, it's not Java. I used Django, Python-based, hosted on a Linux virtual private server with Apache and SQLite. So I did some performance testing, simulating load with Locust, 2,000 users, and it was absolutely horrible. 29% failure rate, error rates, and response times, page load times peaking at 40 seconds, which is completely unacceptable. So the first thing I did was replace SQLite with MySQL. SQLite is fast in a single user context, but it basically does logging on the entire database, no concurrency. And that improved things a lot, but still not perfect. So the failure rate is a lot lower, but there are still peaks of, I think, page load times of 50 seconds. So the second thing I did was change Apache for Nginx. I didn't expect it to make the difference that it did, but it's so much better. It was so much better. It was, yeah, if you see the response times, the scale is totally different. Everything is within a fraction of a second. So that was great. So I was ready for the event. Was it necessary? Well, this was the sort of the traffic that the site received over the month of March. You can see there was indeed a big spike on the 12th of March, where we ended up on the front page of Hacker News. But still, I think a maximum of 70,000 requests during the day. That's one request per second on average. It was fine. It probably would have been fine if I had kept the original stack. And yeah, here you can see where the traffic came from. So indeed, some from Hacker News at one point, and from Reddit, yeah, all various social media sites. And then, what was nice to see is that it was really a competition. So I made some announcements. I tried to raise some awareness, and yeah, there were really people trying to compete every day for the fastest time. Right? You can see there. Response time, like the moment I published the puzzle at 12 UTC, within a few minutes, people have already solved it. So that was great to see. Then, of course, the puzzles get more difficult later on, and so really takes more time. You can see later on it's 20 minutes, 27 minutes, an hour, and the final puzzle took 3 hours to solve. And there were really people still going for it. And I was feeding hints on Reddit and on Discord, and until finally somebody managed to solve it. But then I want to talk about the first one. The first puzzle had a solution time of 13 minutes, and that's actually quite high for the first puzzle, which should be the easiest, right? So what happened? Well, what happened was 12 o'clock arrived, 12 o'clock UTC, and it was 1 o'clock for me at the time. And no puzzle. And I was behind the scenes frantically checking everything. And people were in Discord panicking. I need to breathe. And my colleague Jesse messaged me, it would be ironic if this was a time zone issue. And I was there checking, no, it was all set to UTC, it was all set correctly. That wasn't it. So I did a quick hack on production, editing the server live. If puzzle ID equals 1, then released equals true, just to make sure that people could get started. And later on, I figured what the actual problem was, and it was this. Can you spot what I did here? So this is the patch that would have fixed the problem, or that fixes the problem. It's in Python, I know, not Java. And what you see here is that I'm attempting to inject the now function so I can override it for testing purposes. And so the idea was then I inject the time before release, check that it's not released, inject the time after release, check that it's released. But I wasn't injecting the now function, I was injecting the result of the now function, which was the time at the time I started the server, I guess. So it could never switch state from not released to released. And I didn't have a test for that. So even with test-driven development, testing time-based things is tricky. So that was my most embarrassing mistake. And it was the only big mistake that happened during the event. So I guess that was good enough. On day 5, somebody submitted the solution in just 20 seconds. How is that possible, right? I published the puzzle, and 20 seconds later already a result. Well, Alan Taylor submitted this puzzle, and I found out the reason was he watched my DevOps presentation of last year. So that's why I gave the spoiler warning, because I should have done that last year. That, yeah, basically Alan looked at the presentation for hints on how to solve the puzzles faster. So Alan is my best student, but did he win in the end? Well, it turns out, no, because one time he slept through his alarm. Wait a second, what? So I released the puzzles at 1 in the afternoon, and he was setting his alarm at 1 in the night to be the first to solve the puzzle. Alan is from New Zealand. Imagine the dedication. Huh? But one day he just slept through his alarm and yeah, missed the opportunity and dropped a few spots in the ranking and never completely recovered. So in the end, the winner was Mr. Tiefeld. So congratulations. By the way, I'm mentioning these names. I talked with them. They were okay with being mentioned in the presentation, so don't worry about that. And yeah, I mean, the traffic we had, so at the time I had 300 people try the first puzzle, so it's not as much as Advent of Code with 250,000 programmers, but still I was quite happy with the result. Any guesses to which programming language was the most popular? I hear JavaScript, I hear ChatGPT. I'll come back to that later. Python. It is indeed Python. And I think it makes sense. But look at Java. Come on, guys. Java, where were you? Java was one of the fewer used languages. This is, by the way, the analysis that I did on the public GitHub repository. So maybe there were a lot of enterprise Java coders that kept everything closed source. That's possible. But no, Python was popular, and I think Python is a great fit with the problem space. I think Rust and Go, not so much. I don't know that they have particular good internationalization support. I think Java's better in that regard. But clearly Rust and Go are languages that people like to try out and like to learn, so that's why they choose those languages, I think. Right, so I will take you through 3 more of the puzzles, the really more advanced ones. And yeah, so to give you some more in-depth look at these puzzles. And puzzle 17 the story is based on Treasure Island. Here you can see the map from the original book, Treasure Island. X marks the spot. And it's also, here we have Tom Scott again. He's much more positive about Unicode than about time zones. He calls it UTF-8 and the Unicode miracle. And I agree with him. So this puzzle is also designed to show you how great UTF-8 is. Because what you get is a bunch of blocks of hexadecimal code. Here you can see it. And you can, I mean, you get it. I added some coloring, and it will be clear later why. But you start with this hexadecimal code, and you're told these are pieces of a treasure map, and you have to stitch them together. And so you can start treating this hexadecimal code as UTF-8 encoded text. And what you get then is something that looks like this. Right? And you can see, maybe at the top, you see maybe the edge of a map. I mean, I added some color to help the interpretation. You can see some wavy lines that are maybe the sea, represent the sea, and then you can see some shallow lines that maybe represent some shallow water, so maybe there's an island there. But it's all about UTF-8. What you can also see is at the edges of the map, you see a lot of these question marks. That's the Unicode replacement character. I have it here on my shirt as well. That's the character you get when basically you have an encoding error. And so, a quick recap of how UTF-8 works. You start with a phrase. In this case, let's say you have the phrase Sacré-Cœur, and you for each letter there's a corresponding Unicode code point. Those are in the middle. And then for each code point, using UTF-8, you translate that to bytes. And if it's like a lower ASCII character, then it translates to 1 byte. But the accented characters can translate to 2, 3, or 4 bytes. So here's how that works. So like I said, the lower ASCII range always translates to 1 byte. And that byte then always starts with a 0. If you have a higher Unicode code point, and then that gets translated to multiple bytes, and then the first byte always starts with 1, 1, a series of 1s, and then a 0. And then all the bytes after that start with 1, 0. And it means that you can jump right into a sequence of bytes and determine if you're at the start of a character, or if you need to go back, or if you need to go forward, and you can determine the length of the sequence. And that's the miracle of UTF-8. So, using this, basically you can also see that the number of 1s in the start byte is equal to the number of the total number of bytes that form the code point. So if you use that information, then the question to you is, which of these puzzle pieces match? So on the left side, you see the end of a treasure map piece, and on the right side, you see the beginning of it. And then the question is, where does it match? So which of these fit together? Who thinks it's the top one? Who thinks it's the middle one? And who thinks it's the bottom one? I see some hands raised here. Indeed, that's correct. That's the only way to form complete, correct UTF-8 code points. And so that's how you solve the puzzle. You can stitch it together, piece by piece, like that. And then you end up with a complete treasure map. And then you can find the treasure. And then you have to submit the coordinates, and then you know if you did it correct or not. So here is a community solution in, this is in Python. And what I wanted to highlight here, I mean, the code is longer than this. And there's like, the rest of the code is basically a backtracking algorithm to try puzzle pieces in different positions. And this is a check function. And basically what it does is test if the arrangement of puzzle pieces is correct. And it basically does that by running the UTF-8 decoder and checking if there's any replacement characters. So it's run with the parameter replace, so it doesn't throw an exception if there is a UTF-8 or a decoding error, but instead a replacement character, like this one. And that was the goal of the puzzles for this. That's why thank you, Glenbow Lake, for demonstrating that. The goal of the puzzle was to have the solution, to make it possible to just check the solution by just running a UTF-8 validator. So then puzzle 18 is about, right to left text. Imagine a money transfer app or a payment request app. And you can enter any expression and it will do the calculation for you. And so somebody can send you a text message with, any valid expression really. And you copy and paste it into the input field of the app. But then there are complaints, because some people complain that the amounts are different than what they expected. In this case, 11 plus 5 minus 15, you expect that to be equal to 1. But what actually happened is that the transfer was 11 plus 15 minus 5 equals 21. And the reason for that is that it wasn't a message from your friend, it was a spoofed message from a hacker who inserted these invisible Unicode code points, causing the text to flip. Because that's all part of the bidirectional algorithm of Unicode. There's a whole bunch of invisible characters that help with arranging these texts. And so the puzzle asks you to take very long mathematical expressions that are riddled with these invisible code points. And you have to basically calculate the result with and without applying the bidirectional algorithm. And the way that the bidirectional algorithm works, and it's quite complicated, I'm not giving you the full picture here, but basically you have to work from inside out, flip these segments one by one, and then you get this new expression, which you can calculate. And then some example. So this is the example by T-Veld, the winner. I thought it was a really nice and clean example that demonstrates, demonstrates the solution really well. It starts with this. He's just using the Python eval function to calculate the whole mathematical expression. And it just has two processors for cleaning up the code. One is, or cleaning up the expression. So there's the clean method and the flip method. So the clean method just uses a regular expression to strip out all the invisible code points. And the flip method, well, you can see at the bottom is a regular expression that is designed to always take the inner block and flip it around. And so there's some code, a function there also to flip a segment. And if you apply the same regular expression repeatedly, you automatically work your way from inside out to solve the puzzle. So I thought this was a really nice example. And then you may ask, like, why do we even do this? All this complexity, what is it for, right? And it's basically use cases like this where you mix right-to-left text and left-to-right text. So this is a snippet from a newspaper in Hebrew. And you can see that in the top line there, it says Trump Mobile. This is an article about Trump Mobile. I cannot read any of the rest of it. But you can see that it's a bit of left-to-right text mixed in with right-to-left text. Same goes for numbers. And that's not even the problem, because you could say, well, we just use the intrinsic direction of Hebrew characters and of Latin characters. But it's also for situations for characters that don't have an intrinsic direction, that are copy-pasted from a right-to-left text to a left-to-right text. That's what these invisible markers are for. And that's why we get all this complexity. And unfortunately, complexity means an increased attack surface for security bugs. So that's what I wanted to demonstrate with this puzzle. And here's a more practical example, because I know that these puzzles are all very contrived to work as puzzles. But this is something that you can still do in Windows 11 today. Is this an exe or not? Well, it is, because we put a right-to-left override invisible character in there. And then if you assign also the icon, which you can do, you can assign an icon to an exe, so you can make it look like a Word document. And this is is it a security flaw? Well, I think Microsoft hasn't fixed it, so they consider it a feature, not a bug. But it's something definitely to be aware of, that it's possible. And that's what I also try to achieve with this puzzle. How we're doing on time. That's fine. I have one more puzzle to share with you, and that's number 19. And this is the most fun you can have with time zones. The puzzle is called Out of Date, and you have to imagine that you're a researcher at CERN in Switzerland, and you're not a researcher, you're a part of the IT department, and you're responsible for gathering all the data from research stations around the world related to gravitational wave research. And there's research stations, in this example, in Pyongyang, in Casablanca, and in the Casey research station in Antarctica. And so here's the data that you collected, and you're looking for gravitational wave events. And since this gravitational wave is going to hit the Earth at the same time everywhere, you are looking for events that happen at the same time. Fortunately, there's nothing detected. But then you realize perhaps they didn't update their software. because all of these places recently changed their time zones. So in Casablanca, they abandoned daylight saving time. In Pyongyang, they, for political reasons, they wanted to align more closely with South Korea, so they aligned their time zone with them as well. And then a Casey research station, basically at the South Pole, it's either light or dark. It doesn't matter what the time zone is. And so, yeah, they, for political reasons, they flip around a lot. And if you take this into account, if you take this possibility into account, if you assume that they are using local time and they're submitting it using an outdated database, then it actually looks like this. And the stars align, and you have your gravitational wave event. But this puzzle is designed to make you think about where does this time zone information actually come from, right? And so it comes from this. It comes from the IANA, Internet Assigned Numbers Authority, and they publish frequent updates to the time zone database. Here's the announcement mailing list, and you can see in each announcement there's something like, okay, there's something happened in the Philippines, and something happened, something changed here, and something changed there. And yeah, I remember that one point when this news of in North Korea that they changed their time zone, I remember the next day in the stand-up, my colleague asked, should we do something about that? It's a valid question. I mean, not that we sell a lot of software in North Korea, but still you want to know where that information comes from. Usually it comes from operating system updates, browser updates, Java updates. But if you run an older version, then you might have a trouble. By the way, there was actually during the puzzles, I got a few bug reports from people that said that they tried to solve a puzzle which had the time zone Ciudad Juárez in it. Ciudad Juárez was a newly created time zone because they recently changed. And it's like the city didn't have a time zone before, but they made some changes. So it was introduced, and some people had trouble with that, and it turns out they were all C++ programmers. So if you're using C++, you might want to check your time zone database version. This is a solution which I want to highlight by M. Schaik. And okay, so here is a bit of code that you can run on the command line with curl to fetch specific versions of the time zone database. And then here is the code to actually compile that and then start making use of that. And notice that it's using the deprecated JodaTime library. This is a code is in Kotlin, by the way, but it runs on the JVM, of course. And so I thought this was really nice use of a legacy library to solve this problem. There's a more modern way to do it, or there's a more current way to do it, which is to run the time zone updater utility, which Oracle provides. But that one modifies the JVM installation. So that means that you cannot do it in one script, or you cannot do it in a running JavaScript. So I thought it was really nice to see this legacy library come back. And then also this puzzle makes you wonder, should we store all this information, right? If the time zone database version matters, maybe we should store that in, or if we really want to keep track of time. Well, I mean, this actually was inspired by a talk last year by a forensics expert. And if you're in forensics and you are dealing with lawsuits where a lawyer could come in and kind of say, well, you didn't keep track of that, so your lawsuit is invalid, then it might be relevant. But for most cases, still the best approach, if you're talking about instance in time, just use UTC. Because the whole premise of this puzzle was that these research stations were using local time. They should have used UTC and the whole problem would go away. And that's the end. So I have to thank the people who helped me out by contributing, testing, feedback on the puzzles, etc. It was a lot of work to get it all together. You can reach me on Blue Sky if you have questions. Please go and try the puzzles for yourself. The ones that I just spoiled for you, you can do in a different programming language or something like that. And I will keep it online, and it's intended really to be a learning resource. So also share it with colleagues. And that's what I wanted to share. And we're good on time, so if anybody wants to ask a question, I see a question right there.
A question regarding this constant change in time zones. Is there any way that this updates can automatically push somewhere, like for example, JDK?
So the changes in time zones are automatically pushed with JDK updates. So if you just stay up to date with the latest JDK version, then you automatically get them. Well, that's a good question. I don't know. I think if you have like a minor update of the JDK, then it will include also the latest time zone version, time zone database version. Yeah, you have to, yeah. Right.
About storing the moments in time. I once, way before, read some article and it was stated that the good approach for storing the timestamps is to store in UTC if it's in the past, because it's already happened and it cannot be changed anymore. But if you have to store a moment of time that will happen in the future in some location, you better not even try to store it as a time zone, because the time zone of the location may change. As you said, for example, in Adelaide or in Martijn may change. But especially just store a country and a real geographical location, and when something will be closer in time to this, for example, if you have a conference that is set in Brussels in 8th of October.
So your question is, shouldn't we put use UTC when storing time zones in the past, and use something different, like a more complex scheme for storing time zones in the future? Well, if you think about it, if you think about things that are instants in time, then UTC is always correct, because UTC is not a time zone. UTC is the absence of time zones. Right? And so if you're talking about, okay, so take example, let's take, for example, flights, right? Flights happen in the future. A flight can be scheduled. And this is something that actually happened in Chile. There was a change in the time zone, in the daylight saving time in Chile, but they announced the change just a week before it happened. So that was like crazy. And of course, a lot of flights were already scheduled and were already stored in databases. So how do you deal with that? Well, the thing is, the instant that the flight arrives isn't going to change, because it also depends that it leaves some other place, and there it's also fixed, right? So the moment in time, the UTC timestamp doesn't change. What changes is the local representation of it. And in Chile, they had to fix that by manually adjusting the boarding passes. And yeah, that's of course crazy, but that's an unusual situation.
It is a good cause, but in the situation when you have something global, such as a flight, because the flight is global, you cannot move it.
Yeah.
Right? It's scheduled. But if you have something local, say the conference starts in time.
Yeah. Okay, if you have something local, then you're no longer talking about an instant in time. Then you're talking about a time of day. And then it's different. Then I agree. Then you use local time. Yeah.
I would say never use local time. Think, for example, local time in Belgium. In a couple of weeks, we will have to switch to winter time. There will be 25 hours in one day. There will be 2 moments in time that will be represented by the same local time string. It's ambiguous. Even if you use local time, it's ambiguous. Never do it.
Yeah, never use, I agree with you, never use local time when representing instance. But when you represent time of day, it depends on the situation. You can say lunchtime is at 12, and if people switch to daylight savings time or not, lunchtime is still at 12, right? You're just hungry earlier or later, right? So yeah, but then, so yeah, there's a lot of edge cases you think of, but if you think it through, when it's about instance of time, also in the future, UTC works better. So that's at least my opinion on this. Any more questions? If not, thank you for your attention.